Hey, welcome back. Now that we understand binary data, buffers, and character encodings, we're now ready to move on and discuss how to deal with files inside of Node. Now, before I start to talk about what exactly a file is and how your operating system handles files and where exactly Node will come into play here, let me just quickly show you an example of how to deal with a file inside of Node. So what I want to do is to open up my terminal, and I have created an empty folder called app. And inside of it, I'm going to create a new file called app.js. And I'm just going to open up this folder inside of my code editor like this. All right, now, before I write any code, I'm going to go ahead and create a file in that folder, in that app folder. And I'm just going to call it text.txt. And inside of this file, I'm just going to put some random text. So some random text. Now, what I want to do inside of Node, I'm going to grab the contents of this file and log that onto the screen. So it's a pretty straightforward process. So all we have to do is to require the fs module. So I'm going to say const fs equals require fs. Using this module, we could deal with files, we could write files, we could read files, search in directories, and all of that kind of good stuff. So with this in place, I am now going to read that file. So I'm going to say fs.read file, and let's search synchronously. In this case, we're going to talk a lot more about these concepts, but let's just stick with the synchronous manner. So read file sync, and right here I have to specify a path. Now my path is in the same directory, so I'm just going to say text.txt, like so. And I'm also going to save the contents inside of a variable like this. So const contents equals the contents of this read file sync function. Now with this in place, we could now log this content onto the screen. So I'm going to say console.log content. All right, let's now run this and see what we're dealing with. So inside of my terminal, I'm going to say node app.js. And as you can see here, we're getting back a buffer. Now, if you recall from the previous video that we talked greatly about buffers and binary data, you should know that everything you have on your computer is just zeros and ones. And in Node, we have this buffer module to deal with those zeros and ones. So when you try to read a file, you are getting zeros and ones. And with this buffer module here, you could actually, well, read them. You could do encodings on it, convert it back to string, or maybe convert a string to binary, and a lot more that we talked greatly in the previous video. So if you don't understand what this buffer is, please go ahead and watch that previous video on this playlist. Now, each one of these zeros and ones, so they are representing those zeros and ones in hexadecimal format. Each sequence of bits represents a character. So this sum here might mean, I'm not sure, but maybe this zeros and ones. This O might mean another sequence of bits. Now what we could do is to use character encodings to convert this binary data. Remember, this content just holds some zeros and ones. We could convert it into a string. So what I can do here is to run the toString method on that buffer, on that zeros and ones, and just specify character encoding. In this case, I'm going to specify it as UTF-8. Now if I go back to my terminal and run that file again, in this case I am getting some random text. All right. Now in this video we're going to create a complete application, and while doing it we're going to learn a lot more about the fs module. So I just want to show you a quick demo of the application that we're going to build. So what we're going to do right now is to go ahead and create this application together, and by doing that we'll learn a lot more about the file system in Node.js and also some more Node.js concepts. So let me just show you this quick demo. This is the application we're going to build. This is the code, and we're going to clean this up a little bit. This is just what I did right now. I need to clean this up before we write it. But anyway, let me just show you what this application does. Now what it does is that it constantly watches a file that I created here, and it's called command.txt. And what it does is that I just throw some command in here, and the application is going to watch them, and it's going to do those commands. So I could create files here, I could delete a file, I could add to a file, and
all of that kind of good stuff. So let me show you just some examples of how this works. So what I can do here is to just write some commands. So I'm going to say create a file, and then the name, I could just say test.txt, or I could specify the whole path. And in this case, I'm going to specify the whole path. So I'm going to right click here, and I'm going to click on copy path, because I'm going to create this file in my directory, because we could see it that the file appears right here. So I'm going to paste that in, users, Joseph desktop, app, and then in this folder, which is my working directory, this app folder, I'm going to create a file called, I don't know, my new file .txt. And if I save it, Node.js is going to watch this, and it's actually watching it right now. It's going to see this command, create a file, and then it's going to create a file with this path name. So if I save, actually, sorry, I need to start the application first. So I'm going to say node app.js. And now if I save here, I'm going to get that file here on my directory. Now, some of the other things that I could do is to delete that file. So I could just say delete the file, and then if I save, the file is gone. I could then create it again. So create a file. In this case, I'm just going to name it test.txt. We have the file right there. We could actually rename the file if you want. So we could say rename the file this, and then to this. In this case, I'm going to say the new name. And if I save, if you watch here, the file name is going to change. Now we have the file with the name, the new name. And what else we could do? We could also, if I take a look at the commands, we could also add to the file. So I could say add to the file this, and then I guess it was, let me just take a look at the command. Yeah, it was this content. So I could say add to the file this content, and then here I just specify some things, maybe hide there, and then on a new line I could say let's go out. And I'm also going to change the file name to the new file name. So the new name, actually, it's the name of this file that we have right now in our current working directory. And now notice now this file is now empty, but if I save here, if I go back to the file, I now have those two lines that I added. I could add new stuff here if I wanted to. I don't know, maybe some text, and then some more text. Maybe I want to add in some gibberish like this, more, and then some more. Doesn't make any sense, but anyway, if I save it, if I go back to my file, I see that I have now those stuff that I specified here. So yeah, this is pretty much it about this application, and we're going to build this application together in this video. Now, one thing that I'm going to point out is that in this application, we're just using the fs module. So we're not going to use any third-party packages, we're not going to use any other native Node.js modules, we're just using this fs module. So we're using this to watch that file whenever we save the file, and then we're reading those commands, and then we're executing them. And yeah, this is pretty much it. Now, before we start to write this program, before we start to build it, let's take some time and try to understand what exactly files are. So what in the world a file is? What does a file represent? So now we're going to take a moment and have a small discussion about files in general. So we're going to step away from Node.js for just a second and try to understand some concepts in the operating system itself. So let's first talk about what exactly is a file. Now, the concept of file is very general, but we could say that a file is a sequence of bits, meaning of which is defined by the user, maybe someone who has created the file, or you as someone who wants to open that file. And I say the meaning because each sequence of bits might mean a different thing depending upon how you want to decode that data. So in the case of a text file, a certain sequence of bits might mean a character, maybe character C. Now, the same sequence of bits, the same data, if the file is an image, might mean a completely different thing. So it might mean something that's associated with an image, maybe like a color code or the location of a pixel.
So it's important that we say how we want to open the file, how we want to decode those zeros and ones. Now, everything you have on your computer is just a file. So your storage device, your hard drive, SSD, anything, really your flash disk, your USB, they're all divided to files. In other words, a storage unit of a storage device is a file. Now, file could represent different things. It could represent a program, or they could represent maybe some data. Data could mean an image, a video file, or something that's in a free form, like a text file, like a JavaScript file. So that's really what a file is. And now let's take a look at a diagram. So you have your hard drive, and you have written some data on it. Remember, data is just some zeros and ones in a computer. So this is your hard drive, and this is all of your data. Now, each sequence of bits here means a file. So this sequence of bits is a file. Now, each file also has some other data associated with it. Now, they are usually saved in some other file, which is called a file data, which corresponds to a file. So in that file data, we have stuff like the name of that file, the protection. Protection means whether or not you could write to a file, or maybe you could just read the file and you can't write to it. Or also if someone else on your computer, so another user, can open that file or not. So these are things related to protection of the file saved onto that file data. We also have the location of a file, which is just a path name. We also have the type, and again, using these types, we could actually know how to interpret the file. Either it's an image, or if it's a text, or anything else. So depending upon the type of the file, we open that file differently. We use different decodings to open it. We might use a character decoding if it's a text file, or we might use an image decoding if it's an image file, or a video decoding if it's a video, or any other types of decodings. We also have some timestamps associated with the file. When was the file last opened? When was it last modified? When was it created? And things of that sort. And also some other stuff which is really not important, so we're not really going to dig too deep into this. So this is what a file is, just a sequence of bits. And now maybe another sequence of bits here is another file. And actually every bit that I pick here belongs to a file. Okay, so your whole hard drive is divided into different files. You cannot write anything on your hard drive unless you write it to a file. So everything you have on your drive is just a file. And actually your whole operating system itself is just different files, okay? Everything you have on your computer, they're all just files. In fact, let me show you some examples. So if I open up my terminal, now right here, I could run some commands like ls or mkdir to create some directories. But if I run a which mkdir, now the switch itself is also another file, another program. But if I run this which mkdir, it's going to give me a path. And bin mkdir. And let me just go ahead and open that path up pretty quick. Okay, so here's the bin folder, and as you can see here, I have all different kinds of commands that I execute on my terminal, like the echo commands or the ls commands. If I run ls here, I could list all the files and folders, which is when I'm running this, I'm actually getting this, I'm actually executing this file, okay? So it's part of my operating system. I cannot delete these, but they are just files. And if I right click and say get info, well, here I could see the file data, its kind, in this case it's Unix executable file, and I could see the size, I could see its location, when was it last created, and some other timestamps and other data associated with it. So everything you have on your computer is just a file. And actually your operating system itself could only execute the executable files. So my operating system itself does not have any idea whatsoever how to open an image file or how to open a PDF file. Now what happens is that in a lot of cases, in my case I have Mac OS operating system, there are also some other applications shipped with it. In my case, Preview, right here, it's just an application that I could use to open image files. So it's not really something related to my operating system. Well, actually it's related, but it's not really my operating system at its core. Now, my operating system itself only knows how to open executable files right here, as you can see, Unix executable files. So I could just double click on them, and without the use of any other decoder or any other application, my computer is going to run it. So each executable file is specific to a specific operating system and a specific CPU type. All right? Well, that's a little bit more information that you need to know, but the point is, everything is just a file. In fact, my applications, they're all just files. If I go to my applications, well, my calendar app, if I right click and click on show package contents, I'm going to see a whole bunch of different files that when I execute that application are going to come into play. So I have another Unix executable file here, some data associated with a file, and many other things. So everything is just a file. Now, let's now talk about how Node.js deals with files, because, well, dealing with files is very important. Everything we have is a file, and we need to have a way to deal with them. Node.js is a server-side technology, and as a server-side technology, you need to have a way to deal with files, right? So what exactly happens when you try to, I don't know, maybe delete a file using Node.js, or when you try to append some data to a file, or you try to rename a file? How exactly Node.js does that? So let's go back to the slides and talk about this for a minute. So we have our hard drive again, and then on top of this hard drive, we're running our operating system. Now, if this kind of sounds weird to you, you gotta go ahead and watch my video about the video that's called Node.js Under the Hood. I really talked about how these kind of work. So you have your hardware, and then you're running your operating system on top of it. So your operating system is managing the hardware. You also have different processes running. In this case, we have Node.js. So when you run a Node.js application, you're actually opening a new process on your operating system. Now, what happens is that when you're dealing with files using Node, Node.js doesn't have any idea how to go to your hard drive and then find a file and modify the bits there. It doesn't really have any idea how to do it. So it's not going to go directly into your hard drive. So what happens is that Node.js is talking to your operating system. So the way that happens is using some things called system calls. So Node.js using system calls talks to your operating system, and then your operating system goes to the hardware and do some different things. Now, imagine you want to open a file in Node. So you want to open a text file. You're going to call a system call. You're going to tell the operating system that I want to do that. I want to open that file. Now, in this case, you're going to use the open system call. So you're going to run that open call, which is an operating system command, and then your operating system is going to go to the hard drive, find that file, fetch those zeros and ones, and give you the data. And then you could do whatever you want with it. You could maybe open different files using this open system command. Actually, you're not directly calling this open. What you're doing is that you are running a function in Node, and then Node.js using libuv is actually calling this open system call. Okay, it's actually very simple. So you're just talking to the operating system, and operating system here is kind of like a middleman. So it's gonna go ahead, fetch those files that you want, and give you those files. And then maybe you are going to go ahead and then add them together and create a new file containing those 3 files, and then write that file again onto the hard drive. So you might use another system call. I actually don't remember what is a system call for writing a file, but you could use that system call to write that new file onto your hard drive. So we have different system calls. We also have a rename system call. So you could call this rename and then change the name of a file. You don't have to memorize these system calls, but it's kind of good to know what is happening behind the scenes. So Node.js is using libuv to do these. It's using your libuv to call these system calls and to get those zeros and ones, or to write those zeros and ones onto the hard drive. And there's also this thing inside of libuv called thread pool, which we're not going to get into it right now, but later on in the course we will get into it. So Node.js is using different threads to deal with the files. If you are really doing some heavy calculations on the files, you're actually really exhausting that thread pool, and you might want to come up with different solutions. Actually, you know what, we're going to get into it later, but right now I just want you to be familiar with the terminology, and that's thread pull, which we will get into later on, but that is inside of libuv, and one of the things that it does is handling the files. Alright, now that we understand the file system in general and how files are handled in the operating system, and what really Node.js does when you try to deal with the files using the fs module. Now that we have some kind of rough idea about them, let's now go ahead and start to write some code. But before we do it, before we try to create a file or delete a file or something like that, it's important to know that in Node.js we have 3 different ways to do the exact same thing. So we could either use the promises API, or we could use the callback API, or we could use the synchronous API. So 3 different ways to do the same thing in Node using the file system actually. So if you want to create a file, you could either use the promise API, so you could create the file using promises, or you could use the callback API, or you could do it synchronously. So we have these 3 ways of doing the same thing. Now you might be asking, how do they differ? Well, actually, in terms of functionality, they don't. Meaning that if you want to delete a file, it doesn't matter if you use the promise API or the callback API or the other one. The file is actually going to get deleted, and it doesn't really matter which one of these you use if you just want to delete a file. Now, in terms of how they do it, well, it's a little bit different. Now, you might be asking, how and which one of these should I use in my applications? Now, to answer your question, I should say that in general, maybe 90% of the time or 99% of the time, especially when you're just starting out, stick with the promises API. Okay, so if you're just starting out, use the promises API as much as you possibly could. It's a lot cleaner, and I think they have implemented all of the functionalities using the promises API. I'm not quite sure, but I think as I was reading the documentation, I didn't see any function that wasn't implemented using the promises API. And when you really want to have the maximum amount of performance, now in very rare cases when you're doing something really complex and it takes a ton amount of CPU computational power, in those cases you might want to stick with the callback API. And I'm saying this actually based on what Node.js documentation says. It says the callback API in the file system module is faster than the promises API, and use this callback version when performance is really critical to you and you want to have the maximum amount of it. Now, I haven't really done any benchmarking in this regard, but I'll make sure to do some and later on post something on the channel to show you how much faster the callback API is comparing to the promises API, at least in the file system module. Now, about the synchronous API, you just try to stay away from it as much as you possibly could. Only use it when you are dead sure that you have to use it. For example, one case that you might want to use it is that you are trying to read a configuration file before you actually start your application. So you need some of the data in that configuration file to really start your application, and without them you can't proceed, you can't really run your application, and you're going to run into so many different errors. So in a case like that, and it's actually going to happen only once when you're starting your application, it makes sense to use the synchronous API. Actually, you have to use the synchronous API. It will be really daunting to do something like that using the callback API or the promises API. But in general, in 90% of the time, stay away from the synchronous API. There are some cases that you might want to use it, and I'm sure you will figure them out whether or not you should use the synchronous API. But promises API and callback API are a lot faster than this one. Actually, they're not faster, but what happens is that when you are using the synchronous API, you are blocking your main thread. So for example, if someone is uploading a file and you are saving the file using the synchronous API, when someone starts to upload a file, your whole application will freeze. So if you're running only one instance of your Node.js application, only one process, that process is going to get freezed until it's done with the uploading, which is of course not ideal, and you don't want that to happen. But if you use one of these two different asynchronous ways of doing that same thing, saving the file, your application will continue to work just as normal. So it will handle that file uploading, and at the same time it will respond to different requests, and it could actually handle many more file uploadings at the same time. But if you want to do that same thing using the synchronous API, your whole application will just become unresponsive until that task finishes. So you really want to be careful whenever you want to use the synchronous API. Okay, so we have 3 ways of doing the same thing in Node, and now let's jump into my code editor and let me show you the same thing but using these 3 different ways. Alright, so here I'm in my code editor, and I have actually copied this code in so you don't have to watch me typing these. So I have the exact same function, copy file, but I'm doing it using these 3 different APIs. So the first 2 are asynchronous ways of doing it, using the promise API and the callback API, and the last one is using the synchronous API. So what I'm doing is that I'm copying this file. Actually, the name is file.txt, so let me just quickly change it. So I have a file here in the same directory called file.txt, and I'm going to copy this file to a new file, and I'm going to name it something like copied and then the name of the API. So in this case, copied promise, copied callback, and copied sync. And we're going to see how do they differ. Do they actually differ or not? So let's go ahead and try to run some of these. So I'm going to first comment out the synchronous API version and the callback version. And let's just go ahead and run it using the promise API. So I'm going to open up my terminal, and I'm going to run node app.js, and we're not logging anything, but if you take a look here, we have copied the file over, so now we have a new file called copied promise, which has the exact same contents as the file.txt. So far so good, right? And now let's go ahead and do the same thing using the callback API. And I want you to just take a look at the syntax and see how do they differ. If you take a look at the name of the functions are the same, so fs.copyFile. Now in this case we are requiring out of the fs module, but in this case we are requiring out of fs/promises, which again something to keep in mind whenever you want to use the promise API. But in terms of the function itself, they do the exact same thing. I mean, they even have the same arguments. So the first one is my source, and then my second argument is my destination. Now in this case, we are catching the error using try and catch, and in this case, we are catching the error using a callback function. And here we have the error first as an argument, which is pretty common whenever you are using callbacks in Node.js. So you're passing a callback to the function, and always the first argument is an error. And maybe the second argument could be something else, maybe, I don't know, something. But and when you're dealing with Node.js callbacks, it's this error first as argument is very common, and you're going to see it a lot. And also one more point, I said stick with the promise API because it's a lot cleaner. Now in this case, well, the callback version looks cleaner, but the reason is it's just I'm doing this immediately invoked function because I want to make use of this await and async syntax. But in a lot of cases, you don't actually have to do this, and you are already inside of a function, so you just mark it with async, and then you're good to go. So we have these try and catch, but again, it gets a lot cleaner as time goes by, comparing to the callback API, because you might run into callback hell. You might have maybe another callback function here and another inside of it. So in general, just try to stick with the promise API, and only try to do this callback API when performance is really important to you and you want to have the maximum amount of it. Okay, so we ran the promise API version, so I'm just now going to comment this one out, and now let's go ahead and run the callback API. So I'm just going to say node.app.js, and again, we're not logging anything, but if you take a look here in my directory, now I have another file called copied callback, and again, I have the exact same contents. So these two are doing the exact same thing. It doesn't matter if I want to do it using the callback version or using the promise version. They accept the same arguments, the parameters are the same, and well, what they do is the same. Even the name of the functions are the same. Now let's go ahead and do it using the synchronous API. Now in this case, well, we're requiring the fs module just like here in the callback API, but the name of the function is slightly different. So what's different is that we, in the synchronous API, we usually have to, actually I think in all of the cases, we have this sync thing at the end of the name of the functions. So copy file sync, unlink sync, or create file sync. So we have this in the synchronous API because, as I said before, you really got to be cautious whenever you want to use this function. So Node.js kind of wants to make it super clear that you are using the synchronous API. So you have to be careful, and you will know that you are using the synchronous API. So only use it when you are 100% sure that you have to use it. Now in this case, we don't have any kind of error handling in place. If it goes wrong, my whole application is going to quit. But as you can see here, it's really the same thing as this one. So copy file and then source and destination. So let's just go ahead and run this one too. So I'm just going to say node app.js. And again, sure enough, we have copied -sync, which has the exact same contents. So I copied a file in Node using the fs module, but using 3 different ways, either using the promise API or the callback API or the synchronous API. Okay. Now you might be asking, what happens if we have an error? So let's go ahead and try that out too. So I'm just going to change the name of my file, or I might delete it. Actually, I'm just going to add 1 to it because in this case, our source is not going to be found. Now let's try the promise API first and see what kind of error we're going to get. So we're catching the error here, and then we're logging it onto the screen. Simple enough. I'm going to run it, and as you can see, we're getting an object back which has the code of this. So it says that no such file or directory at this source, so it cannot proceed with the copy operation. Now let's go ahead and try the same thing using the callback API. I'm going to run it, and as you can see, we're getting the exact same error, with the exact same error number, code, and it's just the really exact same thing. Now let's try it with the synchronous API. Now in this case, it's a little bit different, but again, the error code and all the rest of the data is the same thing. Now, the difference here is that it is coming differently. So here we are catching the error, and we could handle it. We could do something to maybe proceed with our application if that error happens and not quit. But in this case, my whole application will quit. The whole process will quit as soon as something goes wrong here. So it's kind of like if I try to reference a variable that does not exist, like this. If I run this, I'm going to get an error just like here. Okay, so 3 different ways to do the same thing in Node. Now, in our application that we're going to create, we're going to stick with the promise API. So we're not going to use any synchronous API or callback API, but you should know that they do exist. And I can't comment this out. Okay, so let me also show you how Node.js documentation is indicating these 3 different ways. So I'm just going to search for Node.js file system. Oops, typo, but here it found it. Okay, so if you scroll actually right at the top, here you could see that it has 3 different examples using the promise example, the callback example, and the synchronous example. So right off the bat, you could see that Node.js is saying that you have these 3 different ways of doing the same thing. So if you see that the file system documentation is super long, it's actually because it's describing the same thing but using these 3 different ways, which actually they're all really similar and nothing really different. Now, in the real world, whenever you want to use one of these functions, you might want to come to the documentation. So you really don't have to memorize anything to know that, hey, the promise API uses this set of arguments and maybe the callback API uses those set of arguments. Actually, again, in a lot of cases, they're the same thing. I didn't see anything that was different, but there might be, so it's always good to come here and take a look at the function that you want to work with. So for example, if you want to create a directory, click on it, and in this case, it's the callback version. Now, if we want to see the promise version, just search for that like this, and then you could find here we found the synchronous version. If we keep going, I don't know where it is, but I think it is somewhere around here. If you just keep looking, hopefully I could find it. Oh, here. It's actually fs promises. I didn't know that. So the promises, it's called fs promises, and in the callback, Node.js is calling it fs. But anyway, you could see that it's the exact same function using the exact set of arguments, and then you could also see an example. So always whenever you want to use a function in the file system module, and actually anything that you want to use in Node.js, any kind of function, just come to the documentation and read that through. Okay. And now let's start creating our application. So what I have done is that I have just created an empty directory, and I highly encourage you to follow along as well. So go ahead, create an empty directory, call it whatever you want, and open that up in your code editor. And now I'm going to create two different files. One is app.js, where we're going to write our Node.js code, and another one which is command.txt. And in this file, we're going to write our commands. So what we are going to do is that we are going to watch this file and look for events. Okay, so, and the type of events that we're actually looking for is the change event. So whenever I change this file, I'm going to get the content of the file and see what the user has specified, what the user has commanded to do, what are the instructions, and just go ahead and do that. So the first step for us is to start to kind of watch this file. All right, so let's see how we can do it. Now, if you go ahead and open up the documentation of Node.js and start to look for how you could watch a file, so what you could do is just search for watch, and right here we could find some examples. So if I start from the first one, which is in the promises section, so in the promises API, we have this function available to us called fs.watch. So I'm going to use this function to watch for changes that happen in that file. And I actually read this before, so I'm not going to do it right now, but let's just go ahead and do it. So what we can do is just, first of all, we have to include the fs module, so require fs, and we want to use the promise version, so fs/promises. And then I'm going to create an immediately invoked function just so that I could use the async await syntax. And also just one point that I want to say, it's a JavaScript note. Whenever we're doing this, we're actually, it's not, the only benefit is not that we could use the async await syntax, it's also that we are limiting our scope. So if I define a variable here, for example, const a equals this, I cannot do it again here. I'm gonna get an error that it's a const and you cannot redefine it, but if I move it out of this function, I could do it no problem. So the variables that I have here, variables, functions, objects, whatever, are completely separated from the ones that I have here. So it's a nice technique to use to limit your scope, and I'm not really going to teach you what scope is in JavaScript. If you don't know what it is, you need to learn about it, you need to research, because it's very important, and you gotta learn how scoping works in JavaScript as someone who wants to use Node.js. So I'm just going to say scope. Okay, so if you don't know that, go ahead and search for it and see what you could learn about it, because it's really important. Okay, anyway, so let's now go ahead and start to use that function. So I'm going to say fs.watch, and here we could either specify a file name or we could specify a directory. In this case, I'm going to watch my whole directory, so I'm just going to say /, and then I'm going to save it into a variable called watcher. Now what this watcher is that it's an async iterator. Okay, if you're not familiar with async iterator and async generator, let's just write the code and then I'm going to explain it pretty quick. So now that we have our async iterator, we could go ahead and iterate through it. So I'm going to say for await const event of watcher, and then right here I'm just going to log the event to see what we're dealing with. Okay, and I made a mistake somewhere. Let me just put in the semicolon so that my formatting won't be messed up. Alright, so with this in place, we're now watching this whole directory and we are logging all the events that happen. Again, this is an async iterator, so if you go ahead and search for that in the JavaScript, it's an actually ES6 functionality, so it's just recently came to JavaScript. As you can see, this is how you use that for await of statement to loop through those a function that returns data asynchronously. So you'll see this function here and there in JavaScript. It is usually used for whenever we want to read a data and data is coming asynchronously. So this async generators and async iterators are used in those cases. This is as much as I'm going to talk about this because it's really related to JavaScript and nothing related to Node.js. Although in the link that I have included in the description box that I say learn this JavaScript concept here or learn that one there, I have included a section called async generators and async iterators. So if you want to learn about it, go ahead, open that link up and find that section and read those articles and watch some of the videos that I have included. But if you really don't understand this async generator and iterator and you don't care to go ahead and learn about it, you could just as easily change this to a callback version. And to be honest, it could look cleaner if you are not really familiar with this async generator concept. So you could do that, but I'm not going to do it in this video. So really, it's up to you. If this doesn't make sense to you, and if you don't care to go ahead and learn about it, just change the syntax to a callback syntax. And you could just learn about it here in the documentation. So I think it's called fs.watch. Let's see if we could find that function. Yeah, it's right here. So fs.watch. And then you could see the syntax right here. So you just say watch, some directory or a file name, and then you specify the callback. But I'm going to stick with the promise version. Okay, so with this in place, let's now go on ahead and run it and just get some events, okay? So I'm going to say node app.js, and now this is running. And because this function keeps running, we're not quitting. So what I'm going to do right now is to come to my command.txt file, and I want to issue an event. Now if I change this, and keep in mind that if you're typing right here in your code editor or your text editor application, you're not actually changing the content of the file. So whatever you're doing here, you're doing it in your memory, in your RAM. As soon as you save, you are saving those changes onto the file. So you are going to your hard drive, to your disk, and then you're saving the content there. And at that point, you are changing the file. So right now, no events. As soon as I save, I'm going to get an event right here. And as you can see, it has two different properties. It's an object. We have the event type, which is change, and the file name that was changed. In this case, it's command.txt. Now let's go ahead and play around with it a little bit. So I'm going to create a new file, and I'm just going to call it new file.txt. And if I create this one, go back to my code editor, excuse me, to my terminal, I can see that this time around event type is rename, and the file name is this one. So whenever you delete a file or you rename a file or you create a file, you're going to get this rename event. So if I, for example, delete this now, I'm going to get another rename event type. Now, if you're wondering how in the world how we could figure out if it was an actual rename or if it was, you know, creating that file or if it was deleted, what you could do is to just use other fs module functions to look for that. So if you see the event type, you could just check, see if that file still exists, or you know, some things like that to figure out if it was deleted or if it was renamed or just recently created. But for our application, we don't really care about this rename event. All we care about is the change event. So if I come to this file, or actually any file, so if I create a new file and I start to change the contents of this file, I'm going to get the change event. So if I save, I'm going to get the event type of change. And this is the file name that was changed, file.txt. Now, one thing that's kind of weird is that whenever I'm saving, I'm getting this event type change twice. So I don't have anything, and if I just do one save, actually this time I got one, but sometimes in this case I got two. So what really happens is that I don't know, but I do know that it has nothing to do with Node.js. It is something related with the Visual Studio Code. So if you try to change the content of the file, but maybe using another application like Nano, which is the simplest possible way that you could imagine to edit a file. So if I just try to change the content of that file using Nano, and I just say something and then try to save it, if I go back, I'm only going to get that event type once. So it's just something that's going on with the Visual Studio Code, and honestly, I don't know what this is, but we're not going to care about that because the Node.js is watching, and every time the content of the file changes, it's going to get that event. So I don't know, maybe Visual Studio Code is doing a double save or something like that, but it's not really important at this point. So this is how we are going to watch that file. We're watching this directory and we're looking for really any changes that happen. But we don't need to watch for everything. We just need to watch for the event type that is of change and the file name, which is command.txt. So what I can do is to say if event.event type is equal to change and event.file name is equal to command.txt. Now at this point, well, the file was changed. And we're going to do our operations. So let's just do a quick log. So I'm going to say constant.log. The file was changed. So let's go ahead and try this out. So I'm going to run the application, and now if I delete this file.txt file, I'm not going to see anything in my terminal, so nothing happens. But as soon as I change this file like this and I save, I'm going to get that log. And again, as I said before, we're sometimes going to get that event twice, that change event twice, but it really has nothing to do with Node, and it's something that Visual Studio Code does behind the scenes. But the point is that at this point, we are now ready to read the contents of this file and actually do something with it. So we could watch and see if it says create a file or rename a file or whatever else that we might want to do. Now, one more point is that this watcher, this fs.watch function, it could either accept a directory or just a file name. So if you accept a directory, it's going to watch this whole directory. If I create a new file or if I change really any file, it's going to kick in. But I don't need to do this. All I want to do in this case is to watch this command.txt file. So what I'm going to do is to change this from watching the whole directory to change it to only watch that command.txt file. And if I save, if I run my application again and I save, I'm going to get that change event again. And also, we don't need to now check for the file name, because at this point, when we reach this point, the file name is this one, because we're only watching that file. So what I'm going to do is to just go ahead and remove this second condition. Now what happens is that we are watching that file, and whenever this event type of change happens, now here we are going to do our work. Okay, so let's try this one more time. I'm going to save, and there we go. Alright, so now let's try to read the contents of that file whenever we change that file. So what we need to do is right here in this if statement, when we reach this point, we want to read the contents of the file, right? So that we could see what command has user specified. Now, let's see how we could approach this problem. How do you think we could read the content at this point? Now, the way that it works whenever you want to read something, whenever you want to read a file, is that you first have to open it. So you're first going to open the file, and then once the file is opened, you could either read from that file, or you could write to that file, or append to it, or get the status of that file. And by status, I mean that file data. For example, you want to see when that file was last modified. So you could do all that sort of stuff after you open the file, okay? And it's not really anything specific to Node.js. It works the same way in your whole operating system. In Python, it's the same thing. In C++, it's the same thing. If you want to read the contents of a file, you first have to open it, and then you could read from it. Now, what really happens when you open a file is that you're not actually moving the whole contents of that file to your memory. What happens is that you are just saving a number regarding that file. It's called a file descriptor. Okay, and this is really, you're going to see this term a lot in the Node.js documentation. Well, a file descriptor is just a number that has been assigned to an opened file. So each opened file has a unique file descriptor. Think of it like an ID. So when you open a file, you're going to have this unique number regarding that file. So later on, you could read from it or write to it or do anything else that we want to do with it. So let's just try to do this now. Let's first try to open the file and then let's try to read the file. The way we can do it is like this. We could either open the file right here before we start to watch the file, or we could do it after we started watching that file. And again, at this point, what you want to do is to refer to the documentation and figure out how in Node you could open a file. I already know how to do this, so I'm just going to write the code. But if I were coming here from another programming language, what I would do is to just refer to the documentation and I would just as easily learn how to do it. It's really nothing too complicated, super simple. If you understand the concept, it's really the same thing in different programming languages. So Python, C++, the way you work with files, it's really similar between them. So the way you could open a file is to use the open function available in the fs module. So I'm just going to say fs.open and then I'm going to specify the path. In this case, it's command.txt, and then I'm going to specify a flag. We're going to talk more about what different options we have to specify as a flag, but in this case, I'm just going to specify R, meaning that I'm only going to read from this opened file. I'm not going to write to it. I'm not going to append to it. I'm just going to read from it. And this returns a promise, so I'm going to say await, and then I'm going to save this one to a variable so that I could reference it later on here in this if statement. So I'm going to say file, actually I'm going to say just name it command file handler. Okay, so right now we have this object and we have some methods available to call on it. Now let's go ahead and take a look at the documentation and see what we're dealing with pretty quick. So let's see what this file handler is. So I'm going to open up the documentation, and right here in the promises API, just at the top you could see a class. It says class file handle. So it's a very important class in the Node.js FS module. So right here, let's just try to click on it. So as you can see here, it says it's just an object with a numeric file descriptor. And you could create this class by this function that we just used. So it really isn't the content of the file. When you're opening a file, you're not actually reading the file. You're just saving a number to your memory. So later on, you could read or write or do whatever you want. Okay, so this is the file handle class. And also one more point, whenever you are opening a file, it's very important that you close it when you're done with it. So right here, we're opening a file, but we need to close it at the end when we're done, because you are occupying your memory, and if you forget to do it, you're going to run into some memory issues. So you're going to have some memory leaks if you really try to open a lot of files and then forget to close them. So it's important to close a file after you're done with it. And again, it's the same thing in other programming languages as well. You open a file, you're done, and then you close it. It's like that you're allocating a resource to something, and then when you're done with that resource, you're going to free that resource, okay? Let's now go ahead, let's actually again go back to the documentation and see some of the other functions that we have available. So in the file handle class, the method that I'm going to use to read the content is actually this one, file handle.read. And as you can see here, we have 3 different options, but really they all do the same thing. So the name of the functions are just the same. The way that they differ is in the arguments that we pass to those functions. So if you read the description of each one of these methods, you can see that they are literally the same thing. So reads data from the file and stores that in the given buffer. The same thing here, and then the same thing right here. So really the argument is the only thing that's different between these 3. Right here, you could specify the buffer, offset length, and position. And right here, again, we could specify them all, but in an object, which is a little bit different, but again, It's really the same thing. In the last one, you could specify the buffer as the first arguments and then specify the rest of them in an object. Again, they return the same thing. They return a promise in each one of these cases with the exact same data that we're going to talk about in just a second. So I'm going to read the content right here. If I go back to my code editor, now that I have the file opened, right here I'm going to say fs, actually not fs, but that file handler, which is command file handler. So I'm going to say command file handler dot read. And let's just read it and don't specify anything to it and see what we have. So I'm going to say wait because it's a promise, and I'm going to save it to a variable called content. And then I'm going to log that content to my console. So console.log content. Okay, so I have this file with this text, and now I'm going to run my application. Let's save. And as you can see right now, we have now an object that has two different properties. One is bytes read and another one is a buffer. Now, bytes read indicate how many bytes we have read from that file. In this case, in the first log, it's 11, and in the second log, it's 0. And the reason is we're actually moving the position each time we read from that file. So in the first read, we are starting from position 0, meaning the first character, and then we're going all the way to the end, which is 11, which is our last character. So if I move back to my code editor, and as you can see here, I have 11 characters. So I select all, and right here at the bottom, you can see that Visual Studio Code says that I have selected 11 characters. So for each character, 1 byte will be allocated. And again, if I go back here, if you take a look at the buffer, we have occupied 11 bytes. So if we start to count these, they will be 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and remember, each byte is 8 bits. So this very first byte here, 6e, if I open up my calculator and I switch to hexadecimal, and then I just put that number, 6e, if you take a look here, these 8 bits are what that number is. So this buffer is just holding some zeros and ones. And if I switch to Unicode, you could see that this code is for character n. And if you recall, our text is new content, so our first character is n. So this is our first read. We're reading all the data in that file, which is 11 bytes. Now, one issue with this is that we're allocating a huge buffer just to store 11 bytes. As you can see here, a buffer with a size of more than 16,000 bytes has been allocated just to store these 11 bytes. And don't mind this, it's just something that I did, a copy paste was a mistake. But so let's go ahead and try to fix this issue first. So let's first try to allocate a buffer that has the size that we actually need. So we don't allocate a buffer that's too large. In that case, we were occupying our memory, but we're not actually using that memory. Or we also need to make sure that we don't allocate a buffer that's too small. In that case, we're losing some data. So if we have, let's say, 30 bytes of data in that file and we allocate a buffer with the size of 8 bytes, we're losing 22 bytes here. So we don't want to allocate a buffer that's too large or a buffer that's too small. We need to allocate a buffer that's just the right size. And the way that we can do it is to get the size of our file. So we first have to figure out how many bytes we have in this file and then allocate a buffer that has that size. So let's go ahead and see how we could do this. So the way that we could actually specify the size of our buffer is using one of the arguments that we could pass to this read method. So if you go back to the documentation here in the read functions, you could see that here we could specify it as the first arguments, or here we could just specify it as an option, or here we could just specify it again as the first option. Excuse me, as the first argument, and then specify the rest in the options object. So let's first go ahead and allocate our buffer so that then we could use it right here and then log the contents. Now, before we allocate our buffer, what we need to do is to figure out the size of that buffer. And if you recall from our video about buffer, the way that we could allocate a buffer is just like this. So we call buffer and then .alloc, and then right here I specify the size in bytes. So if I want buffer of size 8, I just specify 8. Anything I could just specify here, but I can just specify a number. And then to get the number of bytes that we need, what I'm going to do is to first of all find out the size of my file. So this command.txt, I need to find its size. Now remember, we already have this file opened, right? When we called this method, we have opened this file, and we could just access this file handle right here and then get the size. So what I'm going to do right here is to just say get the size of our file, and we could just do it by calling our command file handler object or class and then call the stat method on it. If you want, you could go to the documentation and read what this method does. I'm not really going to explain it too much, but in short, it just returns some of the stat that we have available on that file, meaning that file data that we talked about in the slides. The size of the file, some of the timestamps, type, and some other data like that. So let's just go ahead and log this to the console and see some of the data that we have available. So I'm just going to say this, and I'm also going to comment out this line, and let's go ahead and run this. Going to run my application. I'm going to do a save to trigger this change event. If I go back here, you could see that now we have some data available to us. Now, one of these things that is really of interest to us is this size property, and as you can see, it's 11. It's just the right size that we need to use to allocate our buffer. Now, again, we have some other data here available. We have some of the other, we have some timestamps. Now, there are a couple, but some of them, one of them is, for example, the time that the file was created, another one, the last time that the file was modified, and so on and so forth. So let's go ahead and use the size and allocate our buffer. So what I'm going to do is to, right here, that I am allocating my buffer, I'm going to specify this size. So I'm going to save this into a variable called size, and I'm going to get the size off of this thing. So I'm just going to call dot size like this, and then I'm going to pass the size, which is a number. Again, remember the size is this one, the size of our file, which in this case it's only 11 bytes. So I'm going to pass the size right here. And with this in place, we're now allocating a buffer that's just the right size. And if I go ahead and log the content again, if I save, and if I go back to my terminal and run the application again, I'm gonna come here, save. We have an error. I think we're doing something wrong here. Oh, it's not actually a function. I'm calling it as a function, but it should be just a property like this. So let's go ahead and run it again. Save, go back over, and now as you can see, we're allocating a buffer that's just the right size. It's only 11 bytes. But as you can see here, they're all zeros, and the reason is we have actually moved our position when we're reading from that file. So what we need to do is to now change the position of that method. So right here, if I can go back to the documentation, you could see that in the options we could specify the position, the offset, and the length. So let's now go ahead and quickly allocate these right here. And I'm actually going to use the first option that we have. So for the second argument, I'm going to specify our offset, which is the location in the buffer that we start to fill. So in our case, we always want it to be 0. The length is the number of bytes to read. Again, this should be the length of our file, because in each read, we just want to read the whole content of the file, because our file is pretty small. We're only throwing one command at it at a time, so we need to read everything that we have available. And then the position is a location that we want to start reading from that file. Again, in this case, we always want it to be 0. So let's go ahead and specify these 3 arguments. So I'm going to head back over to my code editor, and I'm going to create 3 more variables here. So const, the first one was offset, which is going to be 0 all the time. Then we have our length. Oops. And our length is going to be the size of the size. Actually, you know, we could do it a little bit differently. Let's just move this buffer into its own variable as well. So I'm going to say const buff equals buffer.alloc and size. And then I'm going to pass this one right here, and then I'm going to pass my offset, and then length, and then length if I can type, and then the last one was position. Again, position should always be 0, so let's also go ahead and specify our position, which will be always 0. And for the length, I'm going to specify my buffer size, so I could just say buffer.byte length. Okay. So now with this in place, we should always be reading from the first character of the file. So let's go ahead and give this a shot and see if we're doing it correctly. So I'm going to run this application, I'm going to do a save, and again, as you can see here, the bytes read is now always the length of our file. And we have a buffer that's filled with the data that we need. So again, I want to just say this one more time. In the previous logs, we got buffers that had no data in them. So we had buffer 0000, but in this case, we have some data. And the thing that we changed about our method was this position. So this position indicates from what position in this file we want to read the file. Now, if you don't specify it, it's going to be always updated. So if you, in one read, you only read the first 3 characters, in the next read, it's going to start from the 4th character and moves forward. So in our case, we were reading the whole file, so it started at the 0 and then it got all the way to the end. So in our next read, it started to read from the end, which means that we don't have any more data afterwards, so it was an empty buffer. But in this case, we are always reading from the first character, which is of course what we want. Alright, so let me now try to clean this code up a little bit because it now looks really messy. So what I want to do is to remove these 3 lines, and I'm just going to write some comments. Here, this one is get the size of our file, and then allocate our buffer with the size of file, and then here is our offset, the location at which we want to start filling our buffer, which is going to be always 0. Now, how many bytes we want to read, and the position is the position that we want to start reading the file from. And then right here for the contents, I'm just going to say we always want to read the whole content. From beginning all the way to the end. And there's something else that we can do, and that is that if you go back to the documentation and you come to this class file handle, so you just click on this class file handle, you could see that the documentation says that all file handle objects are event emitters. And we already learned about this event emitter object. So this object, file handle object, is inheriting from this object. So what I can do is to, again, clean this up a little bit more and make use of that event emitter object. So what I'm going to do is to just look for a custom event. So I'm going to say command file handler.on, and I could name my event anything that I want. In this case, I'm just going to name it change because it makes sense. And then I'm just going to pass in a function. And the place that I'm going to emit this event is right here. So every time this change event happens, I'm going to emit an event so that this function here will run. If this does not make sense to you, you gotta go ahead and watch my video about event emitters. You need to understand event emitters in order to understand this part. So I'll assume that you know this, so I'm not really going to explain this much. And right here, I'm going to actually emit this event. So I'm going to say command file handler.emit and then that change event. So what I can do right now is to cut all this code out and then move it to this function. I need to mark this function as async, and there we go. So right here we are having our watcher, and then here we are emitting this change event, which will happen right here. So this function here will handle this change event, which is getting emitted from this place. Now let's go ahead and give it a shot and see if we don't have any errors. So I'm going to head over to my terminal and run the application. I'm going to save, and as you can see, we're getting the exact same result. So this code works well. And I think this looks a lot cleaner than what we had before. So if you want, you could always make use of this event under objects and clean up your code a little bit. So here, this code is only responsible for triggering that change event, and then we're doing all of our computation right here. So the next thing that we have to do is to actually read the content. So we're kind of reading it, but we cannot make sense out of it at this point because we're just getting some zeros and ones, right? So what we need to do is to run these zeros and ones through a decoder so that we have some meaningful data. And I'm just going to say this right here. A decoder gets some zeros and ones, and then it gives us something meaningful. Now an encoder gets something meaningful and turns it into some zeros and ones. Okay? So they're actually doing the exact opposite of each other. A decoder will take some data that we can't understand as humans and turns it into something meaningful, like a character decoder or an image decoder. Now, Node.js only understands a character decoder and a character encoder. It does not understand an image encoder. It does not understand a video decoder. All right, so if you want to do something like that, maybe make sense out of a file that's an image, you can't do it natively with Node. But what you can do is to install some third-party packages that have these decoders in place, these decoders and encoders, so that you could decode and encode images and then maybe combine them together or edit them, resize them, or do whatever you want with them. But Node.js itself only comes in with a character encoder and a character decoder, so you can't really read an image in Node. Well, again, unless you install a third-party package or you try to implement those decoders and encoders yourself, which could be, well, quite a job to do, but, well, if you want, you could do it. All right, so in this case, what we need to do is to run this zeros and ones through a decoder. And another thing that I can do actually is to, because we're allocating our buffer right here, and then we're filling it using this function, we don't actually need to save anything. So I'm going to remove this part. I'm not going to save this promise to anything. So right now I have my buffer, and when I reach this point, I'm sure that I have filled that buffer. So what I can do, instead of logging the contents, I'm going to log our buffer. And let me just remove these two lines, and I'm going to run this again and see our buffer. I'm going to do a save, and as you can see right now, we're getting our buffer, which is exactly the same thing as this one. So I assume that you know how to work with buffers, and you should now be able to go ahead and turn this buffer into a meaningful data, meaning into some characters. Now the way we can do it is to just run it again through a decoder, and the decoder we could use is the toString method. And right here I specify the character encoding, which is UTF-8. And UTF-8 is the default one. So I could just really omit this part, but for the sake of clarity, I'm going to keep it right there. So I'm going to save, try this out again. And as you can see, in this case, instead of getting a buffer with some zeros and ones, we're actually getting a string back. So cool, we managed to get our data. And what we could do right now is to try to do some checkings. So for example, we want to check to see if we have included a phrase, a certain phrase like create a file. We want to run a certain function so that we could go ahead and create a file. We will grab the path that the user has specified in this file along with that command and then do some stuff with that. So a command might be like this: create a file and then the path. So the path could be like this. Users could be an absolute path, or it could be a relative path. It doesn't really matter, but in this case we're going to stick with absolute path. Now, an absolute path is a path that's relative to your whole operating system. So I say something like this. I start from the bare minimum, which is the /route, which you can't really go up any higher. So if I go to my terminal and show it to you, I could go to cd. Actually, I'm going to open a new tab. You could just cd into /, and right here I cannot really go any higher. So this is the root folder, and we are going to specify our paths relative to this one, which are called absolute paths. I could also specify a relative path to my working directory, which is app. So I could just go ahead and say create a file, this.txt, and the file is going to get created right here in my directory. But if I specify an absolute path, I could create that file anywhere that I want in my hard drive. Okay, so let's try to tackle this first command first. So I'm going to check here. What we need to do is to just check and see. Actually, let's just go ahead and save it into something. So I'm going to say const, let's call it command equals this. So now that we have our command, which is a string, which in this case it will be this one, we need to check if we have this phrase in that command, and if so, we're going to get this path and then create that file. Alright, so let's now do our first check, which is for creating a file. So I'm going to say create a file, and I'm also going to say how the command should look like, which is create a file and then path. So when our user specifies this in our file and then saves, we're going to run this code. I mean, this check that we're going to implement right now. So create a file and then the path. So what we can do is to just check to see if in our command we have included this string. So we could use the include method that we have available on the strings. So I could say if command.includes, and then I'll specify that text, which is create a file. Now at this point, we know that the user has said something with create a file in it. And what we need to do at this point is to grab the path. And the way we can do it is by using the substring method that we have available on the strings. So we're going to use two different methods, two different string methods. One is include and another one is substring. And I'm just going to talk about it pretty quick in just a sec. So let's go ahead and grab our file path. So I'm going to call it file path equals command dot substring, and then right here I'll specify this create a file. Just say create a file, and then I also need to add one to it like this. Now let me quickly show you what these two methods do. It really doesn't have anything to do with Node.js, but let's just talk about it for a second. So if I say I have this string var a equals text, I could use the includes method on it. It's pretty self-explanatory. Whatever I specify here, if my string includes that, it's going to return true, otherwise it's going to return false. If I say ext, it's going to be true, but if I say exb, it's going to be false. So this is the first method. Another one was substring, and right now whatever I specify here, an index, it's going to give me all the characters starting from that index all the way to the end. So if I say 0, I'm going to get the whole text. If I say 1, I'm going to get from this second character all the way to the end. If I say 2, again, I'm going to start from this position, which is x, and I'm going to go all the way to the end. So substring and includes, two different string methods that we have available in JavaScript. And again, it has nothing to do with Node. Okay. And what we can do right now is to actually move our commands into their own variables, because as you can see here, I'm repeating this phrase twice. So what I'm going to do is to, right here, I'm going to specify my commands. So the first one, I'm just going to call it const create file command, or just create file, which is create a file. And now I'm going to make use of this right here and also right here. So I'm going to hit Command D on my keyboard and I'm just going to paste. Okay. And now let's go ahead and make use of this file path that we have and go ahead and create that file. So what we can do is I'm actually going to create a new function for creating a file, and I'm going to call it create file. Visual Studio Code did something that I don't want. So I'm first going to define my function right here. So I'm going to say const create file equals this, and it's going to accept a file path like this, or just path. And now I'm going to call this function right here and then pass this file path to it. Okay. Now what I want you to do as a challenge is to go ahead and try to implement this function. So try to create a function that you pass a path to it and then you create a file with that path. And that's it. You just create that file. If it's a text file or if it's an image file, you just create it. Create an empty file, okay? So pause the video right now and see if you could tackle this problem. Now remember that you gotta go to the Node.js documentation and see how you could create files and then try to implement it right here. All right, so I'll see you in just a second. Okay, so hopefully you gave this a shot and you managed to call this function right here and then create your files. So let me now show you my solution. So the way that I'm going to create this file is to first do a check and see if we already have that file in place. We don't want to create it. Okay, so we're just going to return an error that the file already exists. So what I can do is to say file handle maybe exists, and actually I'm just going to call it existing file handle. Makes a little bit more sense. And I'm just going to say wait fs.open and with the path, and I'm also going to specify the flag as read, because in this case again we're not going to write anything, we just want to check to see if we already have that file in place. And I need to mark my function as async. Now if this open function doesn't return an error, it means that it was successful in opening the file, meaning that the file already exists. And well, we just want to return an error and exit out of this function and say that the file exists and we can proceed. So I'm going to say return console.log the file, and I'm going to use ES6 strings to inject a variable right here. So the file path already exists. Pretty simple. And I'm actually going to wrap this around a try catch, because if we don't, well, it's not really going to work. And you'll see in just a second why. I'm going to move this logic right here. And remember, every time you open a file, you gotta close it at the end. So when you're done with it, you gotta close it. Now I'm going to define this variable right here at the top, existing file handle like this. And then right here after my try catch, I'm going to close that file. So let's try to go over this again. So we want to check whether or not we have that file. We already have that file. So here, if we don't return get an error, it means that we do have the file. So I'm going to say we already have that file. And then right here in the catch, if we do get an error, it means that we don't have the file. So we don't have the file. Now we should create it. Okay. Let's now go on ahead and try to create that file. And the way that I'm going to create this file is again by using the open method. So I'm going to say const new file handle equals wait fs.open path. And then I'm going to specify the flag as W, meaning that I'm going to write to it. And just to show you some of the different options that we have available to specify as the flag, you gotta go to the Node.js documentation and scroll right here in the notes section, and here it's the last item that says file system flags. And here we could see all the options that we have available to specify as that arguments. So we used R, which means open file for reading. Now we're going to get an error if the file does not exist. Okay. Now we're also now using this W, which means that it will open the file for writing. Now if the file does not exist, it's going to create that file. We also have some other commands right here that you could take a look at. For example, R+, which means it opens file for reading and writing. And again, an exception, we're going to get an error if the file does not exist. So this one only opens for reading, this one opens for reading and writing. So you might want to come here and take a look at all these flags. It's really easy to understand what they do, so I'm not going to go over all of them. Okay, so I'm going to open this file as W, meaning that if we don't have that file in place, we're going to create an empty file. With this in place, I'm now going to say console.log, a new file was successfully created. And remember, you always need to close a file whenever you open it. So I'm going to say new file handle dot close. Okay. Alright, so let's go ahead and give this a shot and see if we could create some files. So I'm going to save this, and I'm going to go back to my terminal, and I'm just going to run the application. Okay, now here in the command.txt file, I'm going to say create a file, and then let's just call it text.txt. If I save, okay, we have an issue here. First of all, we're not getting the path correctly, and second of all, we are getting an error here. And actually, my bad. If at this point we don't have any file, this is not going to get defined, right? So we're going to get straight to the catch. So I actually should move this one right here. So what happens here is that I just open the file and then close it. If it was okay, it means that we already have that file, so we're just going to return an error. If we do get an error at this point, it means that we don't have the file, so we're just going to create it right here in the catch. And I don't need to do this here, I'm just going to define my variable right here, actually as a constant. Okay, now let's try to troubleshoot our path. So we're using the substring method. We actually need to use the length. Okay, I forgot to do this. So we need to get the length and see how many characters we have there, and then add 1 to it, and then start from here and go all the way to the end to get our path. Okay, so let's try this one more time. I'm gonna go back to my terminal, run the application, and then actually I'm going to delete this file. And now I'm going to do a save, and there we go. Now we have an empty file created in our working directory. Let's check to see if we don't have any error. Nope. File was successfully created. The file this already exists, and it's again because of that double saving thing that happens in Visual Studio Code. So every time you save, it tried to do it twice, so in the second time we say that the file already exists, so we're not going to create it. Okay, cool. And let's also try to create a file maybe somewhere outside of our directory. So I'm going to create a file maybe, I don't know, maybe on my desktop. So I'm going to go to my desktop, and I'm just going to create a directory here, just call it test. I'm going to cd into test, and right here we don't have any files or folders. And now I'm going to create a file right here in this folder, which is on my desktop. So I'm going to copy this path here, go back to my file, and instead of this one, I'm going to specify an absolute path. So I'm going to start from /root, and then users, Joseph, desktop, test, and right here, I'm going to say a new file .txt. And actually, let's just say .javascript, okay? So I'm going to save, come back here, and now we have that JavaScript file created in this test folder. Okay, so it's working pretty good. And now with this in place, let's move on to our second function. And actually, I'm going to do all these if statements right now, and then I'm going to give you a challenge to implement those functions yourself first before you see my solution. So let me do this pretty quick. So here we have creating a file, and then here we're going to have something for deleting a file. So delete a file. The command should look like this: delete the file and then path. So for the if statements, I'm going to say if command dot includes. Let's define that variable. Actually, I'm going to move the variables at the top, so I'm going to cut this out. Then right here at the top of our functions, I'm going to paste my commands. So right here it's create file and then const delete file, which is delete a file. Then we have rename file, so rename file equals rename file, and then last one we have add to file, and this one is add to the file. Okay, so now that we have our commands, let's go back here. Now for this one, it's deleting files, so if command dot includes delete file. Now what we have to do is to first get our file path just like before, so const file path equals command dot substring. And for this one, we have to get this length and then add 1 to it and start from there, and then go all the way to the end, just like here. So delete file dot length plus 1, and that's it. So delete file, you Visual Studio Code. So let's see if we can do it. Okay, delete file and then file path. So this is for deleting a file, and you know what, let's just first add those functions right here. So const delete file, file path, and you have to add an equal sign right here, and then I'm just going to say a log right now, deleting this. And then it will be your job to implement this functionality here. But let's add those two other functions. So another one is const rename file, and we have to first get our old path and then our new path like this, and then I'm just going to say a log renaming old path to new path. Okay, and this should be an arrow function, so let me just add in my arrow. Okay, now last one is adding to the file, and I'm gonna call it add to file. This one we need to get the path and also a content. So we're going to add this content to this path. Here I'm going to say adding to this path, and let's also log the contents. So should be ES6 strings. So right here I'm going to say content is content. All right. So these three functions in place, let's now call them right here. So we're calling it right here to delete a file. And next up, I'm going to write the functionality for renaming files. So rename file. And here I'm going to say rename the file this to this. So we're going to get one path, and actually you just name it, change it to new path. So we're going to give this function a path, and then we're also going to give it a new path. So when we write this in our text file, we want to rename this path, this file, to this one. So our check, so if command dot includes rename file. Now right here we have to do it a little bit differently. So we first have to get the index of this 2, and then start from here up to this 2 to get our first path, and then start from the end of this 2 all the way to the end to get our new path. So let's go ahead and do it. So I'm first going to get the index. I'm just going to call it index, and it's going to be command.index of 2. And I'm also going to add 2 spaces around it. And then I'm going to get the old file path, which is command.substring, and we have to get the length of our command, so the length +1, just like before, and then up until our index. So this is going to start from this portion, so we're getting this length, and then we're adding 1, so we start from the beginning of the path, and then we'll go all the way to the end before the 2 starts. So we're also counting this space. Now let's also get our new path, so new file path. It's command.substring, and actually I think I forgot to say this. You could just specify 1 number here, and if you do that, like here, it's going to start from that character and then goes all the way to the end. But you could also specify 2 different numbers, and if you do that, it will start from this one, and then it goes up until this index. So in this case, it will start from our length plus this part, and then goes all the way to the index, which is right here. It will not go to the end because we have specified 2 different variables, start and finish. Now we're going to do the exact same thing here, but this time we're going to specify only 1 variable, and that's our index. But in this case, we have to add something to our index because our index will be right here. So this index of 2 will return this part, so the first portion of this string, which is right here. Now I have to add like 1, 2, 3, 4 to this one so that I will start from the new path. So index +4, and then go all the way to the end to get my new path. Now with these 2 in place, now we could call our function, so rename file, old path, and then new file path. Oops, some mistakes. So new file path, and then right here, old file path. All right. Now let me also write down the last one, which is adding to a file. So add to file. Command looks like this: add to the file, then path, and then we're going to say this content, and then we're going to specify our content. So if command.includes add to file. Now again, just like before, we're going to get our index and then start from the beginning, go all the way to here, and then stop at this point to get my path, and then once more start from this portion after this content, and then go all the way to the end to get the content. So let's first get the index. So command.index of space this content. So we're going to get this index right before this space. And then I'm going to get the file path. Should be command.substring. Now we're going to start from the end of this command, so add to file dot length +1, and then go all the way to the end of this index. So we're going to start from this beginning and go up. Actually, we're going to start from here and go until our index, which is right here. Index of this content, which is the beginning of this string. Now that we have our file path, let's also get our content. So command.substring substring. Now we're going to get our index, but this time we have to add something to it. So our index right now is this, so we have to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I'm not going to count it. I'm just going to select this part and then look at my Visual Studio Code at the bottom, which says 15 selected. So it means that this string's length is 15 characters. So I'm going to add 15 to it. Okay, so now we have our content and our file path. So let's just go ahead and call that add to file function. So the first argument is file path, and the second one is content. All right. Now before you start your challenge, let's run this and make sure that everything is working as expected. So I'm going to go back to my terminal, run the application, and we're not going to run this one anymore, but let's try to delete this file. So delete the file this. I'm going to save, back over, and well, we're not getting any logs. So let's see what we're doing wrong here. Alright, so I had to pause the video for a second to find this out. And here I'm saying delete the file, but the command is delete the file. So let's just change it to delete the file. And I'm going to run it again, going to save, and sure enough, we get that log. So deleting this. Now this means that we're getting our path correctly, and it's now your job to implement your functionality right here. So you have the path, go ahead and delete it. So this will be your first challenge. Now your second one is to rename that. So let's see if that works well. So I'm going to say rename the file this to, just going to copy this path, paste that in, but I'm going to change the name to new name. Save, head back over to terminal, and now we can see renaming this new file.js to this new name.js. So this is going to be your second challenge, renaming that file. So you have the old path and you also have the new path. Now your job is to change the name of that file, which is this one, to this new file name. Now your third and your last challenge is to implement this add to file. Now we've got to get the content and then add that to this path. Now let's see if this works as expected. So I'm going to go back to my command.txt file and say add to the file this with content. This is some text. Let's just keep it simple. I'm going to save, back over to my terminal, and it's not working. So let's see what we're doing wrong. Maybe our command name, so it's this content. Yeah. So I'm saying with content should be this content. Now I'm going to save, head back over, still not working. So this content, and then here it's add. Yeah, this is I made a typo here, so it should be add to the file. Save, rerun, and then come here to a save, and sure enough, we got that text. So adding to this file with this content. So this is our content, this is some text, and we need to add this one to a new file.js file. Okay, so these are your 3 challenges. Pause the video right now and go ahead and give these a shot. Also make sure to do error handlings. For example, if you're trying to add to a file that does not exist, instead of just throwing an error and exiting out of the application, just log something nice. Maybe the file that you're trying to add some content to does not exist. And also, don't sweat it if you can't get them all correctly. It's fine, really, but the important point here is that you gotta give it a shot. So you gotta try your best. So go to the documentation, read them, and try to figure out how you could solve these 3 problems. The point is that you get more familiar with the Node.js documentation, use your problem-solving skills more, and just, think and see how you could solve these. Alright, so pause the video right now and make sure to spend at least 10 to 30 minutes on it. Alright, so hopefully you managed it, and now I'm going to show you my solution. So for delete file, I'm first going to remove this log. And then what I'm going to do is to just go to the documentation and search for simply delete to see what Node.js offers. So I'm just going to search for delete, and here you can see that it redirects me to this function, fs.promises.onLink. So using this function, we could pass a path to it, and it's going to delete that file. Now here it says if path refers to a symbolic link. Now a symbolic link is just a shortcut. So if I go to my terminal and open this one in my Finder, now here we have our files app.js and command.txt. What I can do is to just right click and then click on make alias. Now it's going to create an alias for me. Now an alias is just a shortcut. It's a file that refers to the original file. So if I double click on it, I'm actually going to open this file up in my code editor, and I have that now on my other screen, but you could just double click on it and you could open the file, but it's not actually the original file, so it's not a copy of that file. It's just a link that refers to that original file. So this is what Node.js means by a symbolic link. And you could make a symbolic link out of anything, maybe out of an application, so that you have a shortcut, you could double click on it, and then you could open the actual program. So here it says that if path refers to a symbolic link, to a shortcut, then that link is removed without really affecting the original file. But if the path refers to an actual file and not a symbolic link, then the file is deleted. Now here it also says see the POSIX onLink documentation for more detail. Now POSIX is just a standard. So it's a standard that we have across different operating systems. And the reason we have this POSIX standard is to make the job of developers easier. So you could develop an application and use these POSIX standard functions on a Mac, and when you ship that application to another operating system that is also POSIX standard, your app will work just fine. So you don't have to spend a ton amount of time trying to make your functions in a way that will also work on the other operating system. So we have these standards just to make this job easier. For example, Node.js is using some of these POSIX standard functions like onLink, which is the same thing if you try to delete a file in C, for example, or even on my operating system itself. If I go back to my terminal, I could make use of this onLink command. So let's see what we have here. If I try to remove this alias, I could just say onLink app.js/alias, and I made a typo, onLink, and now that alias is removed. Now I could use the same exact format in Node.js and it's also going to work. The exact same format in C and it's also going to work. So I have this onLink here in my terminal. You have it in other programming languages that are also POSIX standard, and also in other operating systems that are POSIX standard. So let's try to use this function, this onLink function. So I want to head over to my code editor, and right here I'm simply going to say await fs.onLink, and then I'm just going to pass in the path. I also need to mark this as async, and that's it. All right, let's now try to use this and see if it works. I'm going to run my application, node app.js, and if I change this to delete the file this, and if I save, now the file is removed. But in our terminal we actually have an error, and the reason is, again, because of this double saving thing that Visual Studio Code does. So in the first time we successfully removed the file, but in the second attempt, because we no longer have that file and we try to remove it, we're getting an error. No such file or directory at this path. So let's try to fix this one pretty quick. So what I can do is to just wrap this around try catch like this, and then move this one in the try. And I'm also going to catch this specific error, so I could say if e.error, if e.code actually, if e.code is equal to this, so let's copy this one. What I'm going to do is to just log that no file at this path to remove. But I'm also going to implement an else statement here that if any other error happens that is not this one, I'm just going to say log an error occurred while removing the file. And I'm also going to log the error. Okay, so this should be pretty much it about this function. Now we should have also done the same thing right here. Instead of just if any error happens, we're going to proceed with creating that file. We should only catch the code that corresponds to the file not existing. So right here, if anything happens, really, we're going to proceed with creating a file. So we should do the same thing, but I'm not really going to do it. You go on ahead and do it because this video is getting pretty long at this point, and let's just focus on the main important things. All right, so let's try this one more time. And now, if I first create that file, so create a file this, we now have that file right there. If I try to delete it, if I save, well, actually I should make it to delete the file. If I save, the file is now gone, and in my terminal I don't get any errors. Instead I get no file at this path to remove, which is the second attempt. Alright, so this is our delete function. Now, apart from this fs.unlink function, there's also another function in Node that you could have made use of, and that is called the rm function. So if I go back here, in the fs promises, there's this function called rm. I'm going to click on it. And you could have also make use of this function to remove some files. And as you can see here, it says remove files and directories modeled on the standard POSIX rm utility. And I could also make use of this rm command in my terminal. Now, the difference between this rm function and that unlink function is that using rm you could actually delete multiple files. You could delete files, directories that are not empty, and actually have a lot more power with this function. But with more power also comes greater responsibility, so you gotta make sure that you don't delete some stuff that you don't want to delete. You could just say, let me actually just show you how this function works. So I'm gonna open up my terminal. And using unlink, we saw that I could delete one file. If I create just some files, a.txt and maybe b.txt, and let's also create a directory called, for example, dir. Now, I can't delete this directory using unlink. So I say unlink dir, I'm going to get an error that dir is a directory. I can't also delete multiple files. So if I say unlink a.txt and b.txt, I'll get an error that you cannot do this using unlink. If you want, use the rm function. So using rm, I could delete multiple files, and I could also delete directories, and also delete directories that are not empty. So I could just say rm.txt and b.txt, hit enter, and now those two files are gone. I could also remove this directory, but I have to make use of a tag. So I could say rm-rf dir. And now the directory is gone. Now, -r stands for recursive and f is for forced. So we're going to recursively delete anything that we have right there. Now you could also specify these two options using Node. So you could specify the force, and you could also specify the recursive option, both of which are actually booleans. So you could also make use of this function to delete some stuff, but be cautious when you want to use this. So if you use this one in your program, and then you specified the force and the recursive option to be true, and you might say that, hey, now that I have this, let me change it to something that I could also delete directories and maybe multiple files. Well, it's fine, but if you try to run something like this, rm-rf/, oh god, I'm so stressed right now that I have this on my screen, so let me just delete it. If you run this command, what's going to happen is that your whole computer will be just deleted. Well, actually not everything, but if you run that, your computer will not probably turn on again, and you might have to clean install your operating system. So be really careful about that. If you tried this function and then you just randomly specify / to it, and you're going to run rm-rf/, you're going to run into a ton amount of troubles. Probably you have to clean install your operating system again. So it's true that you could also make use of this one, but actually, you could use this one maybe if you want to delete multiple files, but again, be really cautious about it, because if maybe someone tries to hack it and pass some kind of path that somewhat somehow bypass your validations, they could just delete anything, especially your whole hard drive. Now, there's also another function in Node that you could use to delete things, and in this case, it's rm directory, which could only delete empty directories. So you could also make use of this one, which just removes the directory identified by path. And I also have access to this one in my terminal. So if I again create an empty directory, I could say rmdir dir. And now I don't have that directory, but I could only delete folders that are empty. And Node.js is actually advising to get behavior similar to the rm-rf Unix command, use fs.promises.rm, but with these two options specified as true. Okay, so two more functions you could use to delete stuff. Rm, you can use to delete pretty much anything, folders, multiple files, and also rm directory that you could use to delete empty folders. Okay. And now let's move on to rename file. Now this one should be pretty easy, so let's first remove this log and go back to the documentation and just search for rename. And right here we have that definition. Now this one is the callback definition, so let's actually move all the way up, and here we could see that we have fs.promises.rename. So I'm going to click on it. All right, here we can see that it's a pretty simple explanation, just renames old path to new path, and that's it. So let's try this out. I'm going to say wait fs.rename old path and then new path. Super simple. And also async. And I'm also going to do the same error catching right here. So I'm going to wrap this around try catch. Going to move this right here, and actually let's also add some logs here. So when we have successfully removed the file, let's also say the file was successfully removed, and right here let's say the file was successfully renamed. And then right here in the catch, I'm going to catch for that same error. Let's actually just copy paste this code here, but instead of no file at this path to remove, I'm going to say no file at this path to rename, but also we're going to get this exact same error if new path does not exist. So if you try to rename this path to another path that is in another directory, and if that directory does not exist, we're going to get this exact same error. So no file at this path to remove, or the destination doesn't exist. All right, now let's try this one. What I'm going to do is to say rename the file text.txt to text new file name, actually, to make it obvious, .txt. And we don't actually have that file in place. I deleted it, but if you go to the terminal, you can see no file at this path to rename, or that one. So we're catching that error. But let's first try to create a file, and actually we already have this file.txt, so let's try to rename that one. So rename the file file.txt to that one. If I save, the file is now renamed. Okay, so it works pretty good. Now, using this one, you could actually move files around. So if I create a directory called dir, I could say rename new file name, which is our new name, to dir/that. And if I save, the file will be moved to that directory. Now, if I try to move it to a directory that does not exist, we're going to get that exact same error. So we're handling that one as well. All right, moving on to our last function, which is appending to a file. So what we want to do in this case is to just write some data to an existing file, and we want to keep the existing data in place and then just write something at the end. So what we can do in this case is, well, if you think about it, appending to a file is just writing to it. But we want to do it differently, because if you try to write something onto a file, what's going to happen is that you're going to just remove everything, and then you are going to replace that with the content that you're trying to write. Well, at least by default. But if you go to the documentation and you scroll all the way down to find those flags, here you could see that if you specify the A option, it will open the file for appending. So by default, if you're trying to write, you are going to use this one, just W, and this will actually just replace the contents. But using this -A, actually not -A, just A, you're going to append to the file. So we're going to write at the end. So what we're going to do is to just open the file first and then just write some stuff to it. So let's go ahead and do this. So I'm going to remove these two logs, and I'm going to say fs.open, and I'm going to open path, which is right here, and wait. And I think I marked this one async, but I didn't show it to you, so make sure to do it. And then I'm going to just save this one to a variable called file handle. So now that I have the file opened, but actually now I have to specify the flag to be A. Now, right here we specified it to be just R, meaning that we just want to read from it, but in this case I specified it to be A, meaning that we are going to append to it. Now that we have the file open, what we can do is to just write this content to it. So I'm going to say file handle dot write content. Okay. And if you want, you could take a look at the documentation of this write function as well. Now, with this in place, let's also just do it in a try catch. And I'm not really going to check to see if the file exists or not. You should do it if you want to make it like an app production ready application. But for the sake of simplicity and time, I'm just going to log this one. So if anything goes wrong, we're just going to log it to the screen. All right, so now let's go ahead and give this a shot. I'm going to save, run the application, and now I'm going to say add to the file. And let's first try to create a file. So create a file, text.txt. And I'm also going to delete this directory. Okay, now this file is now empty that we just created. I'm going to say add to the file, text.txt, this content. The content is just going to be hi. If I save, if you take a look here, we now have that content. Now if I try to, let's also just check the terminal. Okay, so we don't have any errors. And let's also add a log. So here I'm going to say the content was added successfully. Okay. And now if I try to add another content, so here we have hi, and the reason that we actually have hi is because of this double save feature. So let's first try to fix this one. So what we can do is to just check if we try to add something twice, we're going to prevent the pending operation. So what we can do is to just define a global variable, and I'm just going to say, I don't know, maybe added content. And every time we append, we write right here, I'm going to say added content equals that content. Okay, so when we write, we're going to save this one to this variable, which is outside of our function. And then right here, before we do anything, right here actually, I'm going to check to see if added content is equal to content. Let's just return and don't do anything else in this function. So its purpose is only to prevent this double save feature of Visual Studio Code. Now, you might argue that what if I want to add something twice? Well, you're right, you can't do it. But let's just stick with this one. It's not really that important. So I'm going to run this application again. I'm going to delete all the content. And let's just try to run this again. Now we have hi, and we have that log. The content was added successfully. And if I just save here multiple times, we're not actually going to add that hi again. Now if I change something about this hi, maybe change it to y, Now in that file we have hi and bye. And just to show you too what is going to be different if we change this flag, so if I change it from A to W and I save and rerun the application, now notice that in our text.txt file we have hi and bye. Now if I just try to do the same thing, add to this file, but let's say some text, and if I save, now if you notice here the previous content is now removed and it was replaced by whatever I tried to write. In this case it's just some text. So it's important what you specify when you are opening the file. So you could specify all these flags right here. A for opening the file, write for writing to it, and actually replacing whatever is already there, reading, and a couple more. So let's change it back to A. And we're now done with the add to file function. Now, another thing that I want to say here is that you could also do it in another way. So in this case, we opened the file first and then we wrote to it. There is also this function in Node, it's called append file. And it's right here, fs.promises.append file. And using this one, you don't have to actually open the file first. Now we don't have an example right here, but if we see the callback example, it's right here, you could see that you don't have to open the file first. You could just call the function, specify the path and the content, and that's it. So you could do it in one step, but actually what's happening behind the scene is that Node is opening the file first and then it's writing to it. And we could take a look at that in the source code. I have it right here, and if you want to open this up, you could just scroll all the way up right here. When the documentation begins, you could see that source code for this module is in lib/fs.js. So just click on it. It will redirect you to the source code for that module. And if you just search for append file, here's the function. Now, if you try to read this, you specify the path and the data. And also, what is going to happen is that Node.js is going to call this fs.write file. Now notice this is the callback version, but it's the same thing in the promise version as well. And by default, the flag that is going to get specified is -a. So you're not specifying any flags when you're calling this function, but by default, Node.js is saying that okay, the flag should be -a. Now you could also specify a flag here in the options, for example, a plus, or I think we've got a couple more, but I don't remember them right now. But you could specify the option, but what is going to happen is that this function is going to get called, which is called write file. So let's also take a look at the definition of that function. And it's right here. You could call this function, specify the path, the data, and then some options. And if you don't specify any flag, it's going to get defaulted to -w. But if you scroll down, what you're going to see here is that this function, the open function, is actually getting called first. So when you call that append function in Node, you're actually doing it in a simple step in your code, but actually it's going to do it just like before, just like opening first and then writing to it. So it's going to call this write file function. It's going to pass the flag to be A in the options. Then right here, it's going to open that file with that flag, which is A. And then at the end, it's going to write to it. So this is the callback version, but you can imagine how the promise version would be different. Instead of callbacks, we would have async await. But I just wanted to say that you also have that option to call fs.promises.append file or append file the callback version. But what's going to happen is that Node.js is actually going to open the file first and then it's going to write to it. So whenever you try to read or write to a file, you first have to open it. You cannot write to any file without opening it first. And when you open a file, what's going to happen is that you're just going to assign a number to that file in your memory. So we're not actually moving the whole content into your memory. You're just going to assign something to say that, hey, we have that file open, keep an eye on it, we might want to read from it, or we might want to write to it. All right. Our application is now complete. I have to say that it's not really production ready. We're not handling all the possible errors, and also I noticed something weird when adding to a file with some special characters. So if we try to add something here, if we specify the content, but add some special characters here, this index of might get confused and it will not work as expected. So there are some bugs here and there. And also the code is on GitHub and the link is down in the description box below. If you want to try to enhance the application, maybe add some more functions, fix some of the bugs that might happen in special cases, do better error handlings, and so forth. If you do, please make sure to upload your code on GitHub and send me a link or put it in the comments down below and I'd be glad to take a look at it. So hopefully now you feel a lot more confident using the fs module, and we will definitely use it more throughout the course. In the next video, we're going to talk about a crucial concept in Node, and that is streams. Thanks for watching, and I will see you there.